In this video, we're going to talk about general annuity. We have two types of annuity here, simple annuity and the general annuity. Simple annuity is an annuity where the payment interval is the same. So this is important part here, the same as the interest period. So we consider that simple. But in a case where the annuity, where the payment interval is not the same as the interest period, then we have a general annuity. Now, if we have a simple annuity, the uh, formula will be this. Okay, so that's the formula for the present value and the formula for the future value. Okay, where P is the present value of ordinary annuity and R is the periodic payments. I is the interest per period or annual rate, where is equal to R, which is the rate, and M is the compounding interest, and M is the conversion period in a year. So N is the number of periods, which is T times M, where T is the number of years. The same is true with the future value formula for simple annuity. Let's look at one example here. We have Mr. Reyes would like to save 450,260 pesos for his daughter's college education. How much should he deposit in a savings account at the end of every 3 months for 4 years if the interest is 3.5% compounded semi-annually? Now, if you look at the, okay, what is that? The interest period is semi-annually, okay? And then the payment interval is 3 months, every 3 months, okay? So they are not the same. They are not equal. But this problem is general annuity. Now, we don't have the formula for general annuity yet, but what we're going to do, we'll use the formula for the present and the future annuity. And how shall we do that? This is how we're going to do this. If we can make this quarterly, okay, quarterly for our interest period, then we're good. But the problem here, if we make it quarterly, then the interest rate will change as well. Let's denote it as R prime, because the thing is, we don't know what will be the interest rate if we make this quarterly. And another thing to consider is if we make it quarterly, and we have to make sure that the future value is the same as the future value of semi-annually. So that's what we're going to do. So there are conditions to met. Now, what shall we do now is we'll apply another formula. If you remember, the formula for compounding interest is equal to the amount equals to the principal times 1 plus the rate, and then the compounding period, and that's compounding period times time, the length of time of payment. So that's the formula. So we get used to this formula, and we'll transform this into this form. Okay, this is the relation of the future value and the present value. So remember, in the compounding interest, this is the future value amount, and then the P, the principal, is the present value, okay, for our annuity problem. And then this factor here will be the same. Okay, so we'll be using this formula now. All right, next is, what shall we do then? Now, we'll use the original one. Let's denote this as F2 for our original future value. And then, in this case, if we change it to quarterly, and for the interest rate of R prime, which we don't know, we can change this to F1 such a way that the future value of this converted change interest period will be the same as the original one. Okay, so F1 equals F2. And let's write this now into the formula, this formula. Okay, we have now P, okay, which is the present value, and then 1 plus the rate, which is 0 point 0 point, that's 3.5% is 0.035 over the M. Okay, the original one is semi-annually. How many times is it in a year? Semi-annually, that's 2 times in a year. Okay, and then the M times T, our M is 2, and our T here is 4 years. So times 4. Now I should have written the full value here. M, we'll denote M2, which is the original one, semi-annually. T is equal to 4. The present value is 450,260. Okay, and then what else do we need? The interest rate is 0.035, that is 3.5%, and then every 3 months. Okay, no problem for that. For this side, what shall we do here? Now here we have the same P, and then 1 plus, so our rate now is already R prime here, over, now this is quarterly already, and quarterly, or quarterly means 4 times a year, right? 4 times a year, so that's over 4. Okay, so our quarterly, we can denote that is our M1 here. M1 is equal to 4. This is now the converted compounding period. Okay, and we have 4 times 4 for our T, for the number of years, right? For our T here. Now let's compute this. If we divide P both sides, our P will cancel out. Okay, we can make this simpler. What we want to get is only R prime over 4. Okay, that's what we only want to get here. If we erase both sides by the power of 1/4, okay, 1/4. Here we can cancel out the 4. Okay, a lot simpler. And then what we have left on the left side is 1 plus R prime over 4 to the 4 is equal to 1 plus 0.035 over 2. Then the exponent now is 2. And we can clear this more because we only want this. Erase again to 1 over 4. Remember, this is our M1, right? And this is our M2. Okay, and both sides is raised to 1 over 4. And this is now cancelled out. So what we have left on the left side will be 1 plus R prime over 4 equals 1 plus 0.035 over 2. Then this one, 2 divided by 4 is 1/2. Okay, so finally our R prime over 4 is equal to 1 plus 0.035 over 2 to the 1 half. Transpose our 1 here, we have minus 1. Using our calculator, we can get the value of our rate here over 4 to this one. The result, I already rounded up to this digit. And next, we denote this r prime over 4 into j. Let's go back to the formula of the simple annuity. Now this problem is present value. Okay, Mr. Reyes would like to say this is the present value, the 450. That's the P. Okay, so this is the formula for the simple annuity. Now, for the simple annuity, we have now converted into general annuity. Now, I will change the I into J. Remember, the I is equal to R over M here. Okay, R over M, and our N is T times M, or MT. Now, change the I into J, where J is equal to R prime. This is the converted interest already with respect to quarterly. We have now expressed this into simple formula, simple annuity formula. Okay, so let's use now instead of using I, we're now using J here, looking for the R in this problem. Let's go to this formula now. We have P equals R. It's 1 minus 1 plus J to the negative N, okay, over J. And let's plug down the value of our given. So our present value is 450,260 R, and then 1 minus 1 plus our J now. Okay, our J is 0.0087755 raised to the negative. Now we're using the new, okay, the new M, okay, which is quarterly. That is 4, and the year of the number of years is 4 as well. Okay, then all over J. Our J is again 0.0087755. All right, now let's solve for R. Okay, our R is equal to, we can cross multiply this and put this at the denominator. So let's copy this first. That's 450,260 divided by, now the value for this one is, using your calculator, will be 14.86675678. And then if we divide this using our calculator, gives us 30,286.36 pesos. Okay, so this is the deposit. This is what he needs to deposit quarterly. Now, I would like to show the formula for a J so that we don't need to solve the long process that we had. So what shall we do now? Let's go back to the beginning. We have F1 equals F2. Okay, now the original was this period is semi-annually, right? Now let's write down the formula using the future investment. or from the compounded interest formula, that one. So we have the present value times 1 plus R. Our R is the given interest rate there, the original. And then M, we're using the M2 for the original compounding period. Okay, that is the semi-annually. And then M2 times time. Okay, there you go. And then the conversion here on the left, which is the F1, you have the same future value as we intended to. P, okay, the same principal or the same present value. 1 plus the corresponding R prime that we don't know if we change it to quarterly. Quarterly means 4 times a year. And then, I'm sorry, we will denote this instead to M1, okay, to have a general case. Okay, so we have M1 times T. All right, now here we can divide both sides by P. If we divide both sides by P, our P will cancel out. Okay, and then we can raise both sides by 1 over T. This one as well, 1 over T. Our T will cancel out. Okay, and we will be left with this value on the left side, our expression on the left side, R prime, M1. Okay, this is M1 plus 1 plus R over M2. M2. Okay, next is we'll raise it again to 1 over M1, both sides. And our M1 here will cancel out. So the left side now will become 1 plus R prime over M1 equals, the right side is 1 plus R over M2 to the M2. Multiply that exponents, we have M2 over M1. Okay, and we transpose 1 to the right side, we have R prime over M1 is equal to 1 plus R over M2. Okay, I think there's no need for this one. To the M2 over M1, we transpose the 1 to this side, it would become minus 1. Okay, so this is now our J in general. You can take note this formula so that we can use the simple annuity formula. Okay, finally, we have now the general annuity formula, which is of the simple annuity formula, except that the J is equal to this one. Okay, J is equal to R prime, which is the converted rate already that we don't know. That will be equal to the original future value. And M1 is the converted compounding period as well. That coincide with a payment interval. Let's do another problem here. So we have Jeff has purchased a new car for 1.6 million. He made a down payment of 500K. The rest he borrowed money and will repay it in a monthly installment after 5 years. Now, if the interest rate is 10% compounded quarterly, find the monthly payment. If you observe this, the payment interval is monthly and the period of our interest is quarterly. Okay, so they're not the same, and this time it's a general annuity. What shall we do now is we will change the quarterly to monthly so that they will coincide with the payment interval. Okay, make it to monthly. List down first all the given values here. We have 1.6 million with a down payment of 500. So from 1.6 million, that's already 1.1 million. And that will be our present value, the total present value, which is 1.1 million or 1,100,000 for our P. And then what else? We have T is equal to 5 years. And then the interest rate, this is the original interest rate, which is 0.1, which is 10%. And the M1, M2, okay, let's start for M2. M2 is the original, right? The original is quarterly. That is 4 times. And then the M1 is the converted compounding period, which is monthly. That's 12. All right. And what else do we need? All right, we have everything set already. Let's now solve for our J. Our J is equal to the formula 1 plus R over M2 over M1 minus 1. Let's plug in the values now. 1 plus our R is 0.1 over our M2 is 4. Then 4 over M1 is 12 minus 1. Using our calculator, we have 0.0082648376123. 1, 2, 3. Okay, that's correct. That's our J now. And let's go to the, okay, what is this problem? This is the present. The 1,100,000 is the present. And what we're looking here is the regular payment, the R. Okay, find the monthly payment. Using the formula here, okay, that's P equals R. 1 minus 1 plus J again over J. Let's plug in the values now. Our present value is 1,100,000. Our R is the unknown. And 1 minus 1 plus our J is 0.00826483766. Okay, raised to the, now this is the converted value already. We use the M1. Okay, so remember, use the M1. So the compounding period is M1, which is 12 times the number of years, which is the T is 5. Okay, all over our J, 0.00826483766. Okay, the longer, the more accurate the computation is. And to solve for R, we can cross multiply this. Will become a denominator for our left side and flip it. So we have 1,100,000. And the value for this one, let's use our calculator first. Okay, with our calculator, this value here, we cross multiply it here, becomes 47.15507. Okay, that's it. And then we divide it by this number. Our R is equal to 23,327 pesos. Okay, point something. But this is now the problem. This is now the monthly payment that he needs to pay. Okay, I made a formula here in Excel. Notice there are two formula. This is the formula that we're getting this time. And then the second formula will be the longer one. I'm going to make another video for this. All right, now what are we going to get here is the J. Okay, we have the given values here. We set this all to 0 first. And then this is the converted formula of the general annuity to make it into simple annuity. So this is the present value and the future value. And if the problem asks for the regular payments, so you have to look at it here. And you can also look at you can also check the compound interest formula, future value versus the present value here. All right, let's go to our problem. Let's check it out if this works. So what we're going to do, we'll plug in the values here. The present value is 1,100,000. Okay, and then our rate is 0.1, and then our M1 is 12, our M2 is 4, and our T is 5 years. That's 5 years, and we're looking for the R here. Okay, then finally we go to the regular payments. This is the value we get here, 23,327, which is exactly the same as our computation here, 0.29. This is already rounded off.